Hi, welcome to SS 6.3 Polygons. So first of all, the word polygon, let's have a look at that guy. Poly means many. And gon, in this case, means sides. So a polygon is a many-sided thing. And polygons are two-dimensional. They have a length and a width. So they are not 3D like a prism. They are a plane figure, which means they're sitting flat like on the XY Cartesian plane. That is it. That is what a polygon is. All right, so let's have a look. I can observe examples of polygons, sort them into irregular and regular, and the difference there is, are the sides congruent? If they're all the same size, then we can call it a regular polygon. Listing characteristics of regular polygons, and I think one of the words that you'll see in your textbook quite a bit is attributes. Okay, if you're going to describe the polygons by their attributes. So some of the attributes are what kind of sides they have. And so for example, triangles, there are three different kinds of triangles according to their sides: scalene, isosceles, and equilateral, and I've got some pictures coming up of those. And then you can also classify triangles another way. You can classify them according to what kind of angles they have. Some have right angles, obtuse, and acute. And the cool thing about triangles is that you can have two things happening at the same time, two different kinds of classifications. Gets a little complicated. This next one, I can compare two regular polygons using tracing or measuring to determine whether or not they are congruent. So remember from the previous unit where we talked about orientation, and so turning this square to make it look like a diamond doesn't change the size of the shape. It doesn't change the fact that the sides are all still the same. It just changed the rotation of it. And so still congruent. Congruent means same shape, same size. The same S and S. Same shape and size. I can draw a congruent polygon. I can critique the following statement. We just did that. When viewed from different perspectives, as in turning it, the same triangle can be classified in different ways. So with triangles, yes, they can have sort of two different classifications. Any other shape, it's still that same shape, just turned. I can draw and classify examples of different types of triangles: scalene, isosceles, equilateral, right, obtuse, acute, and explain. So our little shape sorter here, these are the vocabulary words for this unit. Regular polygon means that everything is congruent. The sides are the same size, or the same length. So let's have a look and see which of our polygons in this box are regular. First of all, the circle. Do you think it's a polygon? Does it have sides? Is it, well, it's 1D, it's one-dimensional, it's got that going for it. It doesn't have any vertices, doesn't have any points, it doesn't have any sides, and it is not connected at points. So this is not a polygon. All the other shapes actually, well, this one is not a polygon because it has a curve. Not a polygon, not a polygon. Any other curves? That's a cylinder. Curves. I don't think a crescent is considered a polygon. And this one has curved corners, so that cannot be considered a polygon. Did we get all the curves out? I think so. Okay, so then let's look for a shape that has the same length of sides, and then we can call it regular. So our star has all the same shape, same size. This polygon, this one has 1, 2, 3, 4, 5, 6, 7, so this is a heptagon. This one has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so this is a decagon. 1, 2, 3, 4, 5, 6, 7, 8, octagon. So it is regular as well, and the square is regular. One of the misconceptions is that people think the rectangle should be regular, but if you'll notice, these two sides are short and these two sides are longer, so this is a irregular. This one's irregular because it has a short side and a long side. The pink diamond, I believe, is regular. They look to be about the same. This one is irregular. I think if we dropped this side down, it would only come to here, so this is irregular. They're not all the same. That is irregular. 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 Now let's have a look at that triangle. Do you think that this side and this side and this side are all the same size? Because I think if we swung that over, it would only come to here. So I think our triangle is irregular. So you get the idea. Irregular has different sizes going on. Congruent, we talked about that. Same shape, same size. Okay, so now we have different kinds of triangles. Remember I said triangles can be named by their sides and by their angles. And here are your triangles. And so if we're naming them by the side, in this first example, the equilateral triangle has all three equal sides. They're exactly the same. And so we can say all the sides are congruent, they're all equal, so it's equilateral. In the next one, the isosceles, only two of the sides are the same and the other one is completely different. Okay, so that is your definition of isosceles. It's a tricky one to spell. Scalene has no equal sides. They're all different. So this one might be 2 feet, this one might be 7 feet, and this one might be 9 feet. They're all completely different. Then you can also classify triangles by their angles. If your triangle has one, let's draw one here. Not bad. Okay, if your triangle has one or two acute angles, you can't really call it acute because the third angle is not less than 90. Remember 90 would be that square right there? This one goes beyond that. So this is not acute. It has to have all three, less than 90, less than 90, less than 90. A right triangle has to have one that is exactly 90. And it is impossible to have more than one 90-degree angle in a triangle because a triangle has to add up to 180 degrees. And so if this is 90, the other two have to add up to 90. And so you couldn't have one be 90 and one be 0, right? So that won't work. All three angles need to add up to 90 degrees. The last example is obtuse, and that's what I drew up top here in the red. Because this angle was greater than 90, then it's obtuse. Okay, so it only has to have one angle. Okay, just a quick little review here. By sides, equilateral, they're all the same. Isosceles, two are the same. And scalene, none are the same. By angle, All three angles have to be less than 90 for it to be cute. In a right triangle, it has to have one 90-degree angle, and for obtuse, it just needs one that's larger than 90. Okay, let's talk about quadrilaterals. So quadrilaterals have four sides, so all of these shapes have four sides. There is only, I guess there are two. There are two of these shapes that are regular. The square and the rhombus. And a rhombus doesn't have equal angles because the yellow angles match each other. They're quite a bit bigger, and the green angles match each other. So I guess technically the square is the only true regular. So these are some attributes of shapes. When you go to describe shapes, you're going to use words like parallel, which is the train tracks. Those two lines are parallel. They're never going to meet. They'll talk about what's happening at the corners. They might talk about how many sides. They might talk about what the opposite sides are doing. Who's parallel, who's perpendicular, what the size of the sides are. Right? So for the kite, two of the sides are the same, and two of the sides are larger. And the opposite angles, it's saying this angle and this angle because they're directly across from each other, so they're opposites. Those two are the same. This angle and this angle are the same. So different ways to talk about your shapes, mentioning all of their attributes. These are the regular polygons. Now, guess what? Guess who's not on the list? Rhombus. So the squished square is not a regular polygon. These ones are all named by how many sides they have, and you can actually have an infinite number of sided polygon. And so I'm sure back in the day, lots of Greek guys sitting around in the basement drawing polygons, trying to figure out how to make a perfect circle out of them. So lots of fun. I'm sure they had lots of fun. Here's looking at Euclid. Now, Euclid, the guy in the statue, is the ancient Greek who he's considered the father of geometry. So he was the one who figured out all of these angles and named them all and did a whole bunch of work in that department. So if you don't get this joke, because it is a little joke here, Google Humphrey Bogart Casablanca. Enjoy!